Okay, so this is the second part to the original one that we had started the other day. The other day you guys worked on finding congruent angles. Then I had you do an activity where you had to actually draw a figure, if you remember. I'm sure you do, it was just over the weekend. And then today in class, you had to actually find congruent figures within the angle, within the picture that your friend drew. Some of you I know had to work in the book because you didn't finish your work. So anyways, but you did have to find quadrilaterals, point them out, such things like that. So this time what you're going to be doing is actually finding the angle measures. So how can I find an angle measure when I only know maybe a couple pieces of information? Okay? So it's kind of like putting together the pieces of a puzzle. Okay? So this is example 2 from your notes from the other night. So just do me a favor, because I'm sure you've taken other notes since then. If you haven't, you can just write example 2 and continue the notes. But if you have something else written, then rewrite the objective again, and then write example 2. Okay? So here's my congruent statement, stating that quadrilateral LMNQ is congruent to quadrilateral RSTU. So again, quadrilateral LMNQ is congruent to quadrilateral RSTU. Okay? Now, one of the things I want you to pay attention to here is that these quadrilaterals are facing 2 different ways. All right? So I'm going to mark the angles, or the sides, I should say, that are congruent. This will help us. So line UR here. Which one is that congruent to on the other quadrilateral? LQ, there. Line ST, here. Which one is that congruent to on the other quadrilateral? MN, here. Line UT, here. Which line is that congruent to on the other quadrilateral? NQ, here. And then finally, this line, the last one, is congruent to the last one, this line. So now I see which ones are congruent to each other, or corresponding, I should say. The ones that correspond, all right? So now let's look at our angle measures, okay? This is where it gets a little funny because you have to really adjust how you see this because it is turned the other way. So notice the top of LMNQ, okay? So let me point it out to you real quick here. So here's the top, line MN. And what I want you to notice is that line MN, the top of this one, is not necessarily the top of this one. Those are not both the top. Okay? So I just wanted to point that out to you. All right? So the top of this one is actually the bottom of the other one, here. Okay? So the top of one is the bottom of another. All right? So you just have to be careful once they start taking figures and turning them around like that. You just have to really, really, really watch for that. They try to trick you on that. All right. So now let's look at our corresponding angles. Okay? So I'm going to take angle L here. What does it correspond to in my other quadrilateral? Is it angle T? No, those aren't the same position. It's got to be either U or R, correct? It's R. Well then Q is the other one here. Well then that's the other one here. And then N is here. 1, 2, 3. That means N is here. 1, 2, 3. M, 1, 2, 3, 4. Then M is, those are the corresponding angles. Okay? So now we can actually find the missing angle measures. So here's a missing angle measure right here. It's a question mark, angle R. So I want to find out what is angle R. What's the measure of angle R? Well, what does it correspond to? Let's find one in the other quadrilateral that has one line like that. And it's this one here, L. How much is angle L? 80 degrees. Then that means angle R is also 80 degrees. What else is missing? Where else do you see a question mark? Angle T here, another question mark. So angle T, what does angle T correspond with? Let's see, I have 3 marks here, 1, 2, 3. What does it correspond with up here? Angle N. Angle N is 120 degrees, so that means angle T is 120 degrees. What else is missing? Looks like angle M is missing from up here. Angle M. And what does angle M correspond to? It corresponds to, let's see, it has 4 lines. 1, 2, 3, 4. Angle S. So that's 85 degrees, because angle S is 85, so angle M also has to be 85. And which last one? Angle Q. Angle Q has 2 lines. So which other one has 2 lines here? Angle U. Angle U is 70 degrees. So angle Q is 70 degrees also. So you could use this corresponding angles. You could use the corresponding angles to find missing angle lengths. Okay? So if they're congruent, that means they're the same size. So if angle R is congruent, same size as angle L, and I'm telling you angle L is 80 degrees, well, they're the same size, so that means angle R is also 80 degrees. They're both 80 degrees. Okay. So this is basically what I did here. When I did all these lines, drew all these lines, drew all these angles to find out which ones belong together or were corresponding, and then that helped me find my missing angle measures. Okay? Example 3, using measures in polygons. A polygon is regular if all of its sides have the same length. In other words, they're all equal, congruent. And all of its angles have the same measure. That means equal, congruent. So as you can see, these are pictures of regular polygons. So a regular triangle, all the sides are equal, 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 equal. All the angles are equal, equal, and equal. Okay? So that's what this means. So let's look at this one. If this is a regular pentagon, and one side is 15 feet, AB, so line AB is 15 feet, right? We see that. So then let me ask you a question. How much is going to be line BC? 15 feet. How much is going to be line CD? 15 feet. How about DE? 15 feet. How about EA? 15 feet, right? So, the perimeter of the regular pentagon shown is 75 feet because 5 times 15 is 75. 5 times 15 is 75, so there's 5 sides. Each side is 15 feet. Multiply that together, 75. The sum of the angle measures is 108 times 5 because there's 5 angles. Each one is 108. That's 540. So basically what that means is all pentagons have to have a total of 540, even if their angles are not the same. Okay? So all pentagons are going to measure 540 degrees. That's good information to have. Okay? Because here I have a hexagon, 1, 2, 3, 4, 5, 6 sides. Okay? So for this hexagon, and it's a regular hexagon, so all of its sides are equal. I have 2 triangles and a quadrilateral. Well, we all know that a triangle equals 180 degrees. Here I have another triangle, that's another 180 degrees. And I have a rectangle. How much is a rectangle? Everyone should know 90, 90, 90, 90, 360 degrees. Add them all together. So I have 0. 14 and 8 is 22. 7. So pentagons are 720 degrees. So now we know triangles are 180 degrees. We know Four-sided figures are 360 degrees. We know five-sided figures are pentagons. As you saw on the last page, 540 degrees. Now we know hexagons. One, two, three, four, five, six. Wait, 2, 4, 6. Yeah, okay. Are 720 degrees. So we're learning all the measures that all these shapes have to have. Okay? And this is going to be important for finding missing angles. All right? You already did number 1, by the way, and we did number 2, this one in class, if you guys remember. So we don't have to do this one again. We're going to start at number 3. In number 1, the first one that we did, I'll show it to you again in a second. As a matter of fact, here, I'll just go here and show it to you. So we're looking at this, okay? We're looking at these figures here. In number 1, it tells us that angle M, and don't forget angle M is congruent to angle R, okay? Angle M is 56 degrees. Angle N is 29 degrees. And now they want you to find the measure of angle P and the measures of the angles of the second triangle in exercise 1, in the first one. So we're going to find the measure of angle P. So let's go back to number 1 and find the measure of angle P. Okay? So, angle P. Well, angle P is congruent to angle S, right? And we know what M and N are. So let's look at that for a second. So M is 56 and N is 29. So M is 56 degrees, and angle N is 29 degrees. Okay. I know all triangles are 180, so now I can find the angle of measure P. The measure of angle P, sorry. So I know that 56 plus 29 plus angle P, I don't know how much that is, but I know when I add them all together, I have to get 180 because all triangles are 180. So let's solve for P. 56 plus 29 first is 85. 85 plus P equals 180. Minus 85 from each side to solve for P. (95 degrees). So now I know M, N, and P. I know them all. And they asked me to find the measure of angle S. Well, what is S congruent to? It's congruent to P. That means angle P and angle S are the same. Well, if angle P is 95 degrees, then so is angle S. So the measure of angle S is 95 degrees. So that's your answer for part of this one. Measure of angle P is 95 degrees. And they already gave us the measure of angle M was 56 degrees. They also gave us the measure of angle N was 29 degrees. So now they want us to find the measure of the second triangle. So we know that the measure of angle S is also 95 degrees. Okay? And then the other two angles, we have to find T and R. So what is R congruent to in this one? R has two arches, so does M. So R is equal to M, and T is equal to N. Okay? So R is equal to M, and T is equal to N. So the measure of angle R is equal to the measure of angle M, so that's also 56 degrees. And the measure of angle T is equal to the measure of angle N, so that's 29 degrees. showing that they're all equal. What is another name for a regular quadrilateral? What is the sum of the angle measures of a regular quadrilateral? So quadrilateral, remember, is a four-sided figure. So a regular four-sided figure means it's all equal sides. If it's regular, all equal sides. So what is that called? Your answer would be square. What is the sum of the angle measures of a regular quadrilateral? Well, this angle is going to be 90 degrees. This one's 90 degrees. This one's 90 degrees. And this one's 90 degrees. What's 90 times 4? 360 degrees. And all quadrilaterals are 360 degrees. Okay? So it's a square 360 degrees. Draw a rectangle and mark the congruent sides and right angles. Label the vertices, then draw a diagonal. Explain how you know that the two triangles formed are congruent. Okay, draw a rectangle. All right, I'm just going to draw a rectangle here. That's the first thing they told me to do. Got it. Check. What's my next thing I have to do? Mark the congruent sides. This is congruent to this, and this is congruent to this. Check. Mark the congruent sides and right angles. This is a right angle, this is a right angle, this is a right angle, and this is a right angle. Check. Label the vertices. A, B, C, D. Check. Label the vertices. What's next? Draw a diagonal. Diagonal line, okay? Draw a diagonal line from B to D, or from D to B, it doesn't matter either way, or from A to C, you can also draw a diagonal. So, diagonal. Here we go. Okay? Check. Explain how you know that the two triangles formed are congruent. How do I know they're congruent? Because the sides are congruent. The sides are congruent. And the diagonal placed a short and long side in each triangle. So in other words, I know that this line, which is congruent to the other one, so these triangles have two congruent sides. These two are congruent. This triangle also has this side congruent to this one. So I know these two triangles have congruent sides there. And they both share this dashed line. So I know that's congruent. So all the sides are congruent with each other. In that case, I know the triangles are congruent. Okay? That's it for today. We'll do some work on finding angle measures tomorrow. Have a nice night.